This is a video lesson for examples using the equations for uniform circular motion. The learning target for this lesson is, I am learning to use the equations for circular motion to solve real-world problems. The success criteria for this lesson are, I can use the equation for centripetal acceleration to solve real-world problems, and I can use the acceleration for centripetal force to solve real-world problems. All right, so in this video, we're going to look at some examples on using the equations for centripetal acceleration and centripetal force to solve example problems. So we're looking at example 1 in this slide. So a car moving at a speed of 52.2 miles per hour or 23.3 meters per second travels around a curve with a circular curvature of 43.7 meters in diameter. We want to know the acceleration of the car in meters per second or meters per second squared. Okay, so the equation for centripetal acceleration is v squared over r. So we have the car's velocity, 23.3 meters per second, and we have the diameter. So the diameter, remember, is equal to, diameter is equal to 2 times the radius. So to get the radius, we need to do the diameter divided by 2. So we have the diameter is equal to 43.7 meters. So the radius then is going to be equal to 43.7 meters divided by 2. So that's equal to 21.85 meters. All right, so our centripetal acceleration then is equal to the speed of the car, or the velocity, 23.3 meters per second, and that's squared, divided by 21.85 meters, which gives us a centripetal acceleration of 24.8 meters per second squared. All right, example number 2. In the display window of the toy store at the local mall, a battery-powered plane is suspended from a string and flying in a horizontal circle. So we have a plane. It's got a string, and it's flying in a horizontal circle. And the radius of this circle, or the diameter of the circle, it's the radius, is 1.16 meters. It's going around and around. So we want to know, it takes 2.17 seconds to go around. So we want to know the rate. So we have the radius. So we want to know the velocity of the plane, the acceleration of the plane, and then the net force acting on the plane. So let's look at the velocity first. So velocity, remember, is distance divided by time. So first we have to figure out the distance. So the distance around a circle is the circumference. So the circumference of a circle is equal to 2 times pi times r. So in this case, our radius, we have 2 times pi, and our radius is 1.16 meters. So our circumference then is going to be 7.29 meters. So that's our circumference, so that equals our distance. So then our velocity is going to be 7.29 meters divided by the amount of time it takes to go around the circle, which is 2.17 seconds. So our velocity then is going to equal 3.36 meters per second. So our velocity is 3.36 meters per second. Okay, so now we want to know the acceleration of the plane. So the centripetal acceleration is the velocity squared divided by the radius. So our velocity then is 3.36 meters per second. We're going to square that, divided by our radius, which is 1.16 meters. So that's equal to 9.72 meters per second squared. So the acceleration, centripetal acceleration of our plane is 9.72 meters per second squared. And then we want to know the net force. So the net force, the centripetal force acting on the plane, is going to be the mass times the centripetal acceleration, or velocity squared over r, which we just figured out. So our mass of the plane is a 438 gram plane. We want to convert that into kilograms. So that's going to be 0.438 kilograms times our acceleration of 9.72 meters per second squared. So then our centripetal force is going to equal 4.26 newtons. So the force that it takes to keep that plane flying around in its circle is 4.26 newtons. All right, example number 3. Gina likes to build and fly motorized model airplanes with her dad. She holds a 3.47 meter long string on one end that is attached to a 425 gram plane on the other end. She pulls with a force of 2.92 newtons as it rotates in a circle. The string can be considered horizontal. What is the plane's speed? So we're trying to figure out the velocity of the plane. So our equation for velocity here, once we've solved our centripetal force equation for velocity, we have the square root of the force times the radius divided by mass. So let's look at all the information we have here and what we need. So we're looking for velocity. We have the force that's given to us here, 2.92 newtons. We have the radius, 3.47 meters. And we have the mass. The mass is 425 grams. So we're going to convert that 425 grams. So we have mass is equal to 425 grams, which is equal to 0.425 kilograms. All right, so we'll plug all this into our equation. So we have the force, 2.92 newtons, times our radius of 3.47 meters. All that divided by the mass of the plane, which is 0.425 kilograms. And that's going to give us the plane speed of 4.88 meters per second. Okay, everybody, go out there and keep asking questions. It's how you learn new things.